Hello everyone, welcome to today's class. In today's class we are going to look into conjugation of binomial surds. Now let's read. You see, an expression may contain two terms. For example, 6 minus root 5, 3 root 2 plus 3, 2 root 3 plus 4. If one or both of the term contains a surd, we call this binomial surd. Now this explains what binomial surd mean expression. To rationalize a binomial surd, we use the idea of difference of two squares. For example, to rationalize a plus root a plus b, we multiply it by root a minus b to get, this is where they solve it. When you multiply it out, you now get the final answer. I'm going to show this in the example, which is a rationalized number. You know what it means to the number has been rationalized. There is no longer a recurring number in it. Number a plus b and number a minus b are said to be conjugates of each other. So let me explain this thing. Now, we are dealing with conjugate of a binomial surd. You can see that from what we read from the textbook, we are given something like a, let me say, plus b. Now this is a surd, and if you have been told to conjugate it, what we are just going to do is we are trying to take this surd from this form that has a rational surd to a form that has a rational surd. So what we are going to do is, according to the rule, the conjugate of this is, let me say, conjugate of this is root a minus b. It's just very simple. Just put negative sign in between and you get the conjugate. Why do we do that? Because when you multiply the two conjugates together, you get a rational number. Anytime, any day, you multiply a two conjugates together, you get a rational. What rational number means, you get a whole number. So let's solve this. You have something like root a plus b multiplied by root a minus b. Using the rule we used in the last class, we just have a, it will be root a times root a. Then don't forget this negative sign, so it will be minus root a times b. Then coming to b, it will be plus, since the both sides are plus, b times root a. Then don't forget the minus sign, minus b times b. So what do we get? We have, this is a from our normal rule. This is a, because when two surds multiply each other, it gives you the whole number. Now this is negative and this is positive, so this and this are the same. Okay, let me still show it further. Minus b root a plus b root a minus b square. So at the end of the day, you have a, this is 0 because this is minus in itself, minus b square. So now look at it, we no longer have a irrational surd anymore in it. It's now, everything now is a whole number. Let's assume a is 2, and let's assume a is 2 and b is 1. So the final answer of this will be 2 minus 1, because 1 square is still 1. The final answer will be 2 minus 1 square, which is 1. So now we see that we have a whole number, but if we put that same 2 and 1 here, we'll have something like root 2 plus 1. From here we have it surd, but here we are not having a whole number. This is what conjugate does. It changes a number from its surd form to a rational whole number. So by the time we start solving for examples, you will really understand. Let me solve an example using a real value. Let me say example a. Let me say 2 root 3 minus 4. Now, what do you think will be the conjugate of this? The conjugate of a surd is changing the sign in between. I think I missed it in the first explanation I did. Because here is negative, the conjugate will be the same number, but here will not be positive. So let's give a few examples. Let's say you have, for example, you have root 2 plus 1 what will be the conjugate? It will simply be root 2 minus 1. Just change the negative sign. Leave the number the way it is and change the sign. Let's say you have root 3 plus 2. So the conjugate will just be root 3 minus 2. So that's it. In this case, the conjugate will now be 2 plus 4. Take note, you're only dealing with the conjugate, you're not touching any other thing. So let's multiply out 2 root 3 minus 4. Sorry, I think the book is not showing. Forgive me. So 2 root 3 minus 4 will now multiply 2 root 3 plus 4. So we use our normal rule we did in the multiplication of binomial sort. So we just have something like 2 root 3 multiplied by 2 root 3. That's the first one. Second one, plus 2 root 3 multiplied by 4. Third one, now there is negative here and there is positive here, so minus 4 multiplied by 2 root 3. Final one, negative here, positive here, so minus 4 times 4. So we now go for the whole number multiplied by whole number. Let's jump the step. It will be 4. Why this multiply itself will give us 3 plus whole number multiplied by whole number, that's 8 root 3 minus this multiplied by itself 8 root 3 minus 16. So by the time you check it, these two cancel out each other and you have something like this is 12 minus 16, and the rules I said, let me teach it like a baby, that you have 12 naira and you are owing someone 16 naira, or you have $12 and you're owing someone $16. By the time you pay this person these $12 you will still be owing the person $16 left. So just a simple, but plus 12 minus 16 is minus 4 as a final answer. So this is conjugation of surd. You see that you have a surd like this. By the time you multiply by its conjugate, now you're having a whole number. So for those that ask, people might be wondering, why do we need to do this? You will see it when we start doing when we start solving surds that has binomial surd as the denominator. Remember, during division we always want to take away the surd from the denominator. So this is how we handle it so that we don't have the surd denominator. I'll show you in the next example. Now let's say you have this example to solve. Remember what we did when we are doing division of surd. We always want to make sure that the denominator is a whole number. So the first thing that will come to our mind is, how do we take away this, make this denomination a whole number? That's where conjugation comes in. So we conjugate it. Now bear it in mind that your target is the denominator. You have no business with the numerator. Some people might make the mistake of trying to conjugate the numerator. No, your target is always the denominator. Take that in mind, and always have that in mind. So now we have 2 root 3 minus 2 as a denominator. So what will be the conjugate? As I said earlier, just leave it the way it is and change the sign. 2 root 3, then this sign will now become plus 2. So this is what we are now going to multiply the numerator and denominator with. Remember, when we are doing the single solve, we are just multiplying it. Whatever we have numerator, the numerator we just multiply both numerator and numerator with that figure. But now, because we have a binomial solve, we are now multiplying with the conjugation so that we can be able to make the denominator a whole number. So remember, we now have, if you want to solve for this, it will be 2 root 3 plus 2 all divided by 2 root 3 minus 2. Now we multiply by this conjugate we have here, which is 2 root 3 plus 2 all over 2 root 3 plus 2. Logically, for those that want to ask, this divided by this, a number divided by itself is 1, and a number multiplied by 1 is still that number. So this expression here is still equal to this expression, because this divided by itself is 1, and when you multiply a number by itself, you are still getting the same 1. So that's the logical explanation. So we are just using it to make sure that we change this equation in a form that we want it to be. So let's go. Multiplying the numerator, we still use the normal rule we have. It will be this times this, so 2 root 3 times 2 root 3. This times that plus. Now let me just change this expression to another form so it doesn't confuse us. This is equal to 2 root 3 plus 2. 2 root 3 plus 2, all divided by 2 root 3 minus 2, 2 root 3 plus 2. So this is it. By seeing it in this form, you can now remember that, sorry, God. So this expression is now this. So by seeing it in this form, you can now remember that we are solving the multiplication we did in the last class. So let me continue. So this times this is that, while this times this is what I want to write down now, 2 root 3 times 2. Now go to the second one. 2 times this is plus 2 times 2 root 3, while this times this is plus 2 times 2, all divided by, I'll be solving both the up and the down at the same time, 2 root 3 times 2 root 3. Then this multiplied by this, plus 2 root 3 times 2. Now here there is a negative sign here, so be careful. Minus 2 times 2 root 3. I think it's still minus because I made a mistake. Here is a minus sign. 2 times 2. So let's start solving. This will give me the whole number is 4, while the surd will give me 3, because the surd multiplying itself. Here we have 4 root 2. That's for this expression. For this one, we still have plus 4 root 3, while for this one we now have plus 4. 2 times 2 is 4, all divided by, this is same thing as this, so we are getting the same thing. That's the whole number is 4 times 3 plus, this is 4 root 3, that's 2 times 2, minus 4 root 3 minus 4. Are we following up? So the next one will now be, this is 12 plus, because it 4 root 2 plus 4 root 3. Hope I'm not making any mistake. Yeah, getting it. Then plus 4, all divided by, here we have 12. 4 times 3 is 12, and this will cancel out each other. This minus is 0, so let's leave it minus 4. So we now have 12 plus 4 is 16, plus 4 root 2 plus, I think I made a mistake. This, at this point, what I have here is 4 root 3. I suspected it earlier. Sorry for the mistake. 4 root 3. Obviously, this is 4 root 3 because there is no root 2 in my initial equation, so I don't know how to take For those that noticed it on time, you are a genius. Thank you. So here will now be 4 root 3 2. So because the two roots are the same, we can add it. So when we add it, it will be 8 root 3. Because the two roots are the same. Initially, I did not add it because I thought one was root 2. So this is, let me show, this is 16 plus 8 root 3. All divided by 12 minus 4 is 8. So this is my answer. But because I can divide further, I'll just 8 cancel here is 1, 8 cancel here is 2, 8 cancel here is 1. So my final answer is 2 plus root 3. So you can see this equation has been divided to give us this, because we rationalize the denominator to get 8, but since 8 can divide further, we were able to cancel out and get this. So I'm going to solve one more example so that we can get used to it before we call it a day. I'll look for one of the toughest examples in the exercise and solve. So this is the example I choose to solve. I think this is the toughest in the exercise, number 15, exercise 1H. And this, like, I'm going to combine everything we've done in this class all in one example. So first, this is what we have to solve. The first thing is for us to sort out this square sign. And what does the square sign do? It multiplies a number by itself. So this will now be equal to square root of 3 minus square root of 2 all over square root of 3 plus root 2 multiplying itself, root 3 minus root 2 all over root 3 plus root 2. So first, it's very, very important to also know that this is equivalent to root 3 minus root 2 root 3 minus root 2 all into root 3 plus root 2 root 3 plus root 2. Before I solve this example, there is something I just want to let us know. Whenever you see a number and you are being told to find the conjugate, let me say you get a number like a root a plus b, and you are now rationalizing and solving for it. Normally the conjugate of this should be a minus b, just changing the sign. So the shortcut, instead of going through all those long calculations we are doing, just simply do this square minus this square. Simply say root a all square minus b all square. Whatever you get is a final answer. Because if you notice all the ones we've been doing, notice that at a point we used to, the middle calculations here, we used to subtract them out. So when we get to that point, I will jump the step and show you the answer and still solve it so that you compare the two. Now let's continue. First, I'm sorting out the square sign here. So 3 multiplied by 3 is 3 multiplied by 3 is the same thing, but let me show. 3 multiplied by, so be careful, this is negative sign, so it will be minus root 3 times root 2. The second one, minus, there is a negative sign here, so root 2 times root 3. Now, because there is negative here and there is negative here, the answer will not turn to positive. Root 2 times root 2. That's for the numerator. Let's go to the denominator. We have, just so my hand is not blocking this, root 3 times root 3. Everything there is plus, so don't worry. So this one will be root 3 times root 2, this plus root 3. What am I doing? Root 3. That's root 2 times root 3. root 2 times root 3. This multiplied by this plus root 2 times root 2. So let's solve it further. This and this will give us 3 multiplying itself, minus this will give us 3 times 6. 3 times 2 is 6, minus 3 times 2 again is 6, plus this will give us 2 because multiplying itself. Come under, this one is multiplying itself, so it gives us 3 2 plus this one is root 6. The surds are multiplying themselves, that's why we are getting this root 6. The same thing applies here, plus root 6 plus 2. So this is equal to the whole number plus adding themselves. This is 5. Because it's the same surd, you can add it, minus 2 root 6, all divided by this one adding itself again, 5 plus 2 root 6. Now this is what we get after we finish solving for the square sign. But now in surd, most times, as I said earlier, we don't usually like leaving surd in the denominator, so we'll still have to solve this further. And what method do you think we will use? For those that said rationalization, you are correct. So now this number, what was the conjugate of this number? Simply, the conjugate is simply the same number, but you now have a negative sign. So this is what we are going to use to multiply both the denominator and the numerator. So we'll go further. We have 5 minus this all over 5 plus this. We'll multiply by the conjugate. The conjugate of the denominator, always remember this, not the numerator. All over 5 minus 2 root 6. Now this is equal to 5 minus 2 root 6 in bracket 5 minus 2 root 6 all over 5 plus 2 root 6 in bracket 5 minus 2 root 6. Now for this denominator, as I said, I'll show you something before we'll continue. This is already a conjugate. So what are we expecting to get? We're expecting to get what I told you here. Simply do square of this minus square of that. So if we are to solve it that way, I will have 5 square minus 2 root 6 all square, which will give me 25 minus, that's 2 times 2 is 4, and 6 times 6 is root 36. So which is 25 minus 4 times 6, which is 25 minus 24, which will give me 1. So take note of this answer we got here while we solve the real equation. So here I'm going to have something like, I have to squeeze myself here. 5 times 5 equals 25 minus, because there's a minus sign here, 5 times, it will be 5 times 2 root 6. So this times minus, there's a minus sign here, so 5 times 2 root 6. Why this multiply itself? It will now become plus because it's minus minus, which should give us plus 2 root 6 times 2 root 6. Hope you are following up. Or divided by 5 times 5, 25. Okay, I think I jumped step, but it's okay. 5 times this minus 5 times 2 root 6. Then the next one is this times this plus 5 times 2 root 6. Next one is mind you is a minus sign because this plus and minus is minus. 2 root 6 times 2 root 6. So here I'll have 25 minus 5 distance 10 root 6 minus 10 root 6 plus this times this is 4, while root 6 times root 6 is 6. I'm jumping the step. Then here we have 25 minus 10 root 6 here plus 10 root 6 minus 2 times 2, 4, 6 times 6, jumping step. Root 6 times root 6, jumping step will give us 6. So as we go, we have equal to 25 minus, both of them have the same root, so you can add it. 20 root 6 plus 24. 4 times 6 is 24. So under it we have 25. This is plus and this is minus, so it goes out. So I go to the next one. Minus 24. As you can see, I'm getting the same answer I got here. So this is a shortcut for solving conjugation. You don't need to go through all this long process. Just do this formula of the square of one minus the square of the other one. So we have confirmed our shortcut for conjugation. So the final answer is 25 plus 24 is 49 minus 20 root 6 all over 1. So our answer is 49 minus 20 root 6. So this example summarizes everything we've done in this class. It summarizes the binomial conjugation, also summarizes the binomial multiplication. So this is it for this class. If you have any question, do well to ask in the comment section, and if you notice any mistake, also comment about it in the comment section. Thank you very much.